Basically, we're here today to give you a brief run through on what engineering is, and then hopefully this afternoon, later this morning, get you building some bridges that we can test later in the afternoon. The graduates will help you design a bridge, build a bridge, which we'll then test this afternoon and give out prizes. Right, what is engineering? Basically, we're going to run through a few slides now of pictures. In a second, I'm going to ask you to all stand up, and when you see a picture of something that you think is engineering, I want you to sit down again. Sit down if you think this is something to do with engineering. Got the peer ripple effect. Who recognises it?
Jensen Button.
Why is it Jensen Button?
Because he came from Frome.
Because he came from Frome, he came to this college, yeah. So engineering, in summary, we're looking at things we need to design to solve problems and then go and construct. But it could be anything from natural, genetic, engineering, mechanical, to the physical, civil and structural stuff that most of the people in this room.
Structural engineering is really all about why things don't fall down. Today we're really only interested in engineering structures, and an engineering structure has to have three things to be successful. It has to have strength, so all of the elements that make up that structure have to be strong enough with their mechanical properties to resist the forces applied. And if you can work out how your applied loads are being transferred through your structure, then you will have a successful engineering structure. This is the Pont de Gare in France, which was built by the Romans. This is the longest bridge the Romans built. You need to put your hands together, like this, and then step back to about there, and now you're an arch. And this is Benjamin Baker's fourth bridge, which is a big truss bridge. It's a cantilever truss bridge, so those two arms are cantilevering off that central, off this great big tower. It's very similar to a beam in the way that it works, but it's on such a vast scale that it's very inefficient to fill up all that volume in the middle. So you can make it work the same way as a beam by having single elements in some kind of triangular arrangement between them, so long as they're all strong enough to not buckle. And we do have the Benjamin Baker demonstration.
Yeah. Benjamin Baker was a brilliant engineer, but he was also a brilliant public speaker. And Benjamin Baker's explanation of the fourth bridge was demonstrated using 3 people and some basic equipment. So basically, Cliff and Jordan their bodies are the central towers. Their arms are the top members of these trusses, and they're going to be in tension. And the posts are the bottom members of these trusses, which are going to be in compression. And then Chaz is going to be the train on the central span here. So, Chaz. Sit gently, because it is quite hard. I've done this demonstration. Gently. Right, you can see what's going into tension. Your arms in tension. Can you feel that? Yeah. Feel the pull.
What we would like you to do is spend half an hour, maybe a little bit more because we're kind of running ahead of schedule, drawing out your designs, coming up with some ideas. Each group will get given a roll of tape and a ball of string, some scissors, but you'll have to cost for how much paper and card you require to build your model. Each sheet of paper will cost 1 point, and each sheet of card will cost 10 points. At the end of that half an hour period, we would like you to come up and order your materials.